Alright, so question 3 on chapter 4 says a 6 kilogram box is held at rest by 2 ropes that form 30-degree angles with the vertical. An external force F acts vertically downward on the box. The force exerted by each of the 2 ropes is denoted by T. A force diagram showing the 4 forces that act on the box in equilibrium is shown in figure 5.6. The magnitude of force F is 410 newtons. And it's asking for the magnitude of the force T is closest to. So what I always recommend is to always write out what is given. So we have our mass, which equals our weight, which is equal to mg, our force on that force, which is mass and acceleration, and our cosine of theta, which is going to be our adjacent, which is our hypotenuse. So let's write out. So our weight is m equals g, and our force of the weight will equal to mg, which is 6.0 kilograms times negative 9.8 meters second squared, which comes out to negative 58.8 newtons. Then let's search for our net force, which equals mass and acceleration, and force will be negative 58.8 newtons plus negative 4.10 newtons, which comes out to negative 469 newtons. Now, so let me write out, so this 4.69 newtons is the balance of components, of the components of the 2 tensions in the vertical direction. So in a vertical direction, we're going to have 2 t's cosine of 30 equals the 469. So it's asking us to find the magnitude. So we're going to look for the tension. So if we divide by 2, these 2 cancels out, left with t cosine 30, which becomes 235.0. 234.5. When we divide by cosine 30, our T is 270.7 newtons, which comes out to be 271 newtons. That is our answer. That's the magnitude. So it corresponds to letter B.